This is a video about the electric field problems in the AP Physics 2 multiple choice review, obviously entitling electric fields. So here's the problem. We've got a picture of a proton. The proton is traveling left when it enters a space between two oppositely charged parallel plates, as shown above. Which of the four labeled paths will the proton take? So that's what we're trying to figure out. I'm going to cut to the chase. Before that, you should use the force toolkit. Steps to that are to identify the accelerated system, to define a coordinate system, to draw a force diagram and a motion map, to explicitly write Newton's second law, which is the sum of forces equal to the mass times acceleration, F equals ma. Replace F with the actual forces in your diagram, which you should write the forces in the horizontal and vertical plane if necessary. And you should also insert the values where appropriate. Solve for the unknown. You should also consider that since it's not specified, we should, nor is it relevant to the problem, or well, actually, I'd say it's relevant. The initial velocity should be assumed to be constant. Remember how charges behave. Also keep in mind Coulomb's law, which is part of the second thing that I mentioned. And part 6 is not applicable since we're just trying to figure out the concept of whether or not it's going to take this route. All right. So to cut the chase, answer is B. I'm going to just show you guys the algorithm applied to this problem before I explain why this is the case. So keeping this in mind, we know that a proton's being accelerated. Up and to the right is positive. That'll be a coordinate system. So actually it's going in the negative direction. Conceptually, that's not necessarily important, at least mathematically. So this is a force diagram of the proton as is in between the two plates. These also show, these are the motion maps that also detail its direction. As we can see, it's got constant velocity, but because it's got constant velocity, there's no acceleration. However, since there are forces applied in the vertical direction, there is acceleration, which causes velocity, the vertical velocity, which was 0, to increase, as shown in the graph. And this is what the net motion map would look like if you kind of combine these two aspects. As you can see, it starts like this, and that kind of curls up. These gray parts kind of represent the path after these blue parts. So we know that sum of the forces equal to mass times acceleration. And here, the two forces that are being applied are the forces of the electric field from the positive and the negative plates. So over here, because it's a proton, the positive electric field is causing it to repel, whereas the negative is causing it to attract. That's going to affect its acceleration in the vertical direction. And 6 is not applicable. Over here we see that the force of electric, this is just what I've explained, so yeah. So to explain, I've written a big explanation. Feel free to read that, to pause and read that if you want. I'm just gonna kind of paraphrase what actually happens. So because there's an attractive force, but there are electric forces applied to this particle, it's going to move in the vertical direction. Because the proton's got a positive charge and like charges repel, it's going to be pushed by the positive plate, but the negative plate's going to attract it, so it's going to move towards the positive plate. Now, so that means that C, I think, C and D are correct because they are not directed upwards. You know, both of they're either moving. One of the choices is it being completely unaffected affected, which would be the case if it was neutral, but that is not the case. And the other is going in a path that wouldn't make any sense. And so there's only two paths left. So reason why A is incorrect is because it assumes that it loses enough momentum, or that there's enough of a force that causes it to kind of just stop and then go straight in a diagonal fashion. And there's no real reason for there to be a force. There's no force stated in the problem. The only forces that are apparent are those from the plates. So that wouldn't make any sense. B is the only one that's correct because it takes into account the constant velocity, the momentum of the particle, as it's going to want to continue going in its direction, as well as factoring in the acceleration that it experiences towards the negative plate. Thank you all for watching this video. Like, comment, subscribe, even though no one's probably watching this. And that is all for now. Bye.